Hi, I'm Ryan Alt. I'm a physicist, and this is how to calculate energy transfer in chemistry classes. So the first thing you want to do is identify your system, right? So you could have any type of closed system. It could be a piston inside of a car, it could be anything, but imagine it's just closed so that no energy is being exchanged with the outside environment. Now, if you have two items inside of here at two different initial temperatures, a process is going to occur where they reach thermal equilibrium. So you could have one item with temperature T1, you could have another item with temperature T2. Now they'll exchange energy and T1 will go to T1 final, so we call it prime, and T2 will go to T2 prime. Now if we wait long enough, T1 prime will be equal to T2 prime, and that just means that whatever these two substances are, they'll reach thermal equilibrium in the end. Now, assume they don't, and assume some chemical process occurs so that some of the energy involved goes into a process. So these temperatures won't exactly reflect what they would be if that wasn't the case. So now if we want to find the energy going into the process, we can use the equation change in energy equals Q plus W. Now what is Q and W? So Q is the heat that goes into a system, and the equation is mc delta T. The W is the work going into a system. So if we could imagine our closed system having dimensions, volume or something, and the dimensions were changing, so if you could compress it, we would find there was some work done on the system. Now in our case, the dimensions are staying the same, so there is no work done on the system. The work is zero. And we find that if there is a chemical equation involved in this, some chemical process, delta E will be non-zero. So it might be positive, it might be negative, it just depends on how you think of it, right? So in our case, though, say there is some chemical process, so it's non-zero, and we can find that delta E is equal to M1 C1, which is a specific heat. You can look this up online, and you can find that it's multiplied by delta T1. So that's that T1 prime minus T1. There's one more term. It's involved with the other substance. So you have its mass times its specific heat times the change in its temperature. And using this equation right here, we can find the amount of energy that goes into a chemical process. I'm Ryan Alt, and this is how to calculate energy transfer in chemistry classes.